All right, hi everyone, this is Gigi, and in this video we are talking about techniques for computing limits, part 2. This is part 2, so make sure you watch part 1 on the common ways to compute limits. This is using one-sided limit. Okay, so when do you use one-sided limit? When you have problems like these here that involve absolute value. Well, what do we know about absolute value? We know that the absolute value of some number is itself if it is positive. It is its opposite if it is negative, and that's the definition of limit. Okay, so the definition of absolute value. So when you look at this here, when we're saying the absolute value as x approaches 4, and so what happened when x is 4? When x is 4, first of all, the denominator is 0, so you couldn't just do a direct substitution, right? However, when we have absolute value, we wonder how that can be simplified. How do we write that outside of absolute value? Well, we would note that the square root of x minus 2 is negative. This right here is negative when x is less than 4. But when x is greater than 4, this right here is positive, the thing that is inside the absolute value. So we're going to apply the definition of absolute values to break this expression, this function, into two parts. And this is why we say use one-sided limits, right? So we're going to go from the left and then from the right of 4. So the limit as x goes to 4 from the left, going to 4 from the left mean x is less than 4. That means this right here inside the absolute value is negative. And when that is negative, by the definition, the absolute value of it is its opposite. So we can rewrite that as the opposite of square root of x minus 2, which is 2 minus square root of x. In which case we have 1 right here because they're the same thing, right? A thing divided by itself is 1. So the limit as x goes to negative 4, to 4 from the left, that's the notation for that. Limit as x goes to 4 from the left is 1. Okay, now let's take a look at what is happening when x is approaching 4 from the right-hand side. When x is approaching 4 from the right-hand side, that means x is greater than 4. When x is greater than 4, this part right here is positive. So the absolute value of a positive number is itself. So we have limit as x go to 4 from the right of itself right here. Well, that looks like it has opposite signs of the denominator, right? So when you simplify technically, you should be able to see negative 1, but algebraically what we can show is factoring out a negative, right? So when you factor out a negative, you would have 2 minus square root of x, because when you distribute that end, you'll get what you started here. So when you divide out the common factor, you will get negative 1. Okay, so from the left-hand side, the limit is approaching 1. From the right-hand side, the limit is approaching negative 1. So we can conclude that the limit of this function does not exist at 4. The limit at 4 is not there because the left and the right do not go to the same number. And that is how we use one-sided limit. Now, is absolute value the only time you'll do that? Not necessarily. You may have a piecewise function like this, right? So this piecewise function is not defined at 1, but that's okay because when computing limit as x go to 1, the definition said the limit is this, not necessarily defined at that point, okay? So we are now going to go ahead because it has two pieces to this function, one to the left of one to the right of one, and that's an indication that we need to look at the left and the right and make sure they go to the same number. So approaching 1 from the left, we're looking at the limit as x go to 1 from the left of 4x squared minus 3. That's the continuous function, so we'll go ahead and do a direct substitution. And you will get then the value of 1. Okay, now approaching from the right-hand side, the limits as x go to 1 from the right. We're looking at the 3x minus 2 piece. When we plug in 1, we will have the value 1 as well. So the left-hand side and the right-hand side have the same limit. So we can say that the function has a limit of 1 when x approaches 1, right? So when the left-hand limit and the right-hand limit are the same, we can conclude that the limit at that point is, in fact, that value right there, okay? And that is how we use one-sided limits. Next in the video, you will look at the sandwich or the squeeze theorem.